Okay, this should be a fairly quick video. It's DEB 2016, paper 2, question 6, leaving cert higher level maths. ABC is a triangle such that AB is 8 centimeters, AC is 6, and BC is 12. Given the line segment A to B below, construct the triangle. Okay, so I obviously don't have a math set here, but I'm going to make a good stab at it. Make sure you're using a compass and a pencil. We know this is 8 centimeters long. We know that AC, AC is 6 centimeters long. So put the point of your compass here and make sure the radius of your compass is 6. So line it up with your ruler and draw in an arc that is radius 6 centimeters. Now, if that's 8 centimeters, 6 centimeters is going to be somewhere over here, isn't it? Draw an arc of radius 6 centimeters. Now I'm doing that freehand, but this is 6 centimeters. Then make the radius of your compass 12 centimeters. It says BC is 12 centimeters. And put the point of the compass here. This is 8, 12 is going to look something like this. And draw in a arc of length 12 centimeters. Where those two arcs cut each other is going to be the point C. This distance here is 6 centimeters, making sure you're using a ruler, and this length here 12 centimeters. Then it says on the same diagram, construct the circumcenter. Okay, well, how do you construct a circumcenter? Circum, I think of outside. So to circumnavigate the globe would be to go around the globe. So bisect what is outside the triangle. So you're going to bisect what's outside the triangle, that is the sides. If it said the in-center, you would bisect what is inside the triangle, which would be the angles. Now, we're bisecting the sides. So put your compass down here and make sure it is over halfway and swing an arc. And then put your compass down here, make sure it's over halfway and swing an arc. And where those two hit each other, join it up. Okay, now as I said, this is really, really rough. This is a perpendicular bisector. It's perpendicular and it bisects this side. Then you're going to do the same thing with either AC or BC. So compass down here, make sure it's over halfway, swing an arc. Compass down here, make sure it's over halfway, swing an arc. And where they hit each other, okay, there. Where they hit each other is the circumcenter. Circumcenter. Then if that's the center, you put your compass down on this point, the circumcenter, and stretch it so it's at C, or stretch it so it's at A, stretch it so it's at B. You can see that all those distances are the same. And this is again by hand, not fantastic, possibly the worst circle you're ever going to see, but you should get something like that. I'll actually show you the marking scheme straight away so you have a better idea of what it should look like. So again, this was our 8 that we began with. Then we drew an arc of length 6, an arc from here of length 12. So we construct the triangle. Then you can see they've marked off from compass down at B. They've marked off this arc. Compass down at A. They've marked off this arc and formed the perpendicular bisector. And then they did the same. Compass down here at A, swung this arc. Compass down here at C, swung this arc. Join them, construct the perpendicular bisector. This is the circumcenter out here. And then this distance is equal to this distance is equal to this distance because they're all radii. The next question, I'm actually not going to talk through because look, it's answered perfectly in the marking scheme there. Just sort of have to learn off. A little bit of a rare question. I've never seen it anywhere else. A little bit obscure. But the part B is definitely worth looking at, and I'll go and talk through that now. Okay, so in the diagram, PQ is parallel to RS, so draw that in straight away. I know that they're parallel, and I've highlighted that by just drawing in the arrows. PS and QR intersect at O, which lies on the circle. PO is 3 centimeters, and I've drawn that's given. OS is 5, and SOR, interestingly, is a right angle triangle, or right angle. And as they're straight lines, the angle here must also be a right angle because they're vertically opposite. The angle, if this is a right angle, the angle in a semicircle, think we have a semicircle here, must be 90 degrees, okay? Angle in a semicircle must be 90 degrees. Okay, fantastic. So that also means that the QP is a diameter. QP is a diameter. So this length here is a diameter. And they say RS is equal to X. Prove that PO times RS times OS times PQ is true, or that it holds up. If you think of these as being similar triangles, they are similar triangles. I know this angle is equal to this angle because of the Z shape. They are a Z shape. I think Z goes to the start of the alphabet, which would be A, so they're alternate angles. And they're alternate angles also. I've redrawn my triangles just so I know what I'm referring to. My green angles. So the sides that are equivalent, OP over OS is equal to QP over RS, or well, I'm trying to just build towards this. Because they're similar triangles, I know I'm going to want a PO, and on the other side I'm going to want RS, because I'm going to multiply across by it. And then I have my OS, and on the other side I'm going to want my PQ on the bottom line, because I'm going to multiply across. All I have to do is just multiply across by that PQ and the RS, and that's it, QED done. Hence, find the area of the circle in terms of X. Okay, well, remember, I said this is the diameter. The area of a circle is pi r squared, so I need the radius. So I need half of QP. I need to be able to find QP on its own. So I said QPO is 90 degrees. Therefore, QP is the diameter, and then half of QP is the radius. So QP, or PQ, I've used this line here, and I've divided both sides by OS. So divided by OS to get PQ on its own. I filled in what I knew. I knew PO was 3, I knew OS was 5, and I knew RS was X. And it says I'm allowed to have it in terms of X. So that's fine. I've found PQ, which is the diameter, as I said. I'm going to find half the diameter to find the radius. Multiply fractions together, top by top, bottom by bottom. And then I'm going to put it into the area of a circle. Pi r squared. Squaring this, make sure to square the x and the fraction. So 3 over 10 by 3 over 10 is 9 over 100. X by x is x squared. Make sure you put in your units, centimeters squared. The construction at the start is really important to be able to construct the circumcircle. I would really go back and learn the concurrencies of the triangles, the incircle, the circumcircle, the orthocenter, and the centroid. Those constructions, really, really important to go and have a look at. They're very useful. Hopefully you found the video helpful anyways.